Okay, thank you very much. I think my talk is going to be a little bit different from the previous two. You invited me at the last moment, so I'm going to talk about a little bit about the work we have been doing on evolution and ecological interactions that we think are relevant for this discussion. So I'm going to start with evolution. So evolution affects biodiversity in two different ways. First, it changes how species look over long periods of time by adaptations, natural selection, and mutations. But it also causes species to branch, to split into new species. And this is the ultimate source of biodiversity. And if you look at these species that have branched more recently, they are all similar. For instance, in this example, they are all whales. But each of these species is slightly different and they play different roles in terms of the ecological interactions. So this is something that we have studied in great detail at NEXI with Aguiar. And what you see here, for instance, is the snapshots of a population that is evolving over time. Different colors represent different species, and we want to understand how these species distributed in space and what are the statistical properties of their genetic content. So when you go to ecological interactions, you notice that these interactions mainly occur between species from different groups, from different clades. So for instance, you have trees, you have a herbivore that's consuming the tree, you have a carnivore, you have microorganisms in the soil that are important for the tree, and so on. And this becomes even more pronounced, for instance, if you look at plant pollinator networks, which is a very important type of network these days. So here you have the interaction of two clades, of two groups, main groups. You have plants on one side, you have insects on the other side. And although these plants are all related, these insects are all related, they are not identical. So their interaction, they produce these complex networks that you see here. And when you bring these two pieces of information, evolution and ecological interaction, into fragmented environments, which is what we see today, what you observe is that in each of these patches, in each of these fragments, you only see a part of this idealized network. So small patches, they contain few species, large patches will contain larger species, and you naturally ask yourself, what's the minimum size of these patches that can sustain some biodiversity? And then you have to realize that a patch that is large for a beetle might be very small for a large mammal. So it all depends on the context on what you are looking at. And also, if you look at these patches, you see that some of them are connected. And the network of connections, it also plays a very key role in the sense that if the connections are sufficiently strong, local extinctions can be recolonized by individuals from other patches. So I think the point what I'm trying to make here is that there are several layers of complexity. So you have the layer of evolution that connects the species on a certain level. Then you have these ecological interactions between species of different levels. And this also creates coevolution between different clades. And then when you put this together with fragmented environments, you have a third layer of networks that are very important for conservation and for stability of these species. And I think the message I'd like to make is that we should always try to look at the big picture. And of course, there is nothing new in what I'm saying. It's pointed out in the website of this event that we already know all that, right? We're just not using this information properly. So I think that's all I have to say. I think I went too fast, but time was short, so I think I will just stop here. Thank you very much.